Hello again folks. In one of his recent videos, Brian Lough showed us how to make a YouTube subscriber counter using one of these 64 by 32 LED matrix displays and an ESP8266 Wi-Fi Arduino board. Now, I purchased these parts for another project, but I did want to actually test the display and I used Brian's code to do so, and I am so glad I did. One, it was super easy to use his code and configure it and get it up and running. And two, it has resulted in a super cool, geeky, if I can use that term, display, which looks absolutely fantastic. I really, really like it. So much so that I want to make it into a permanent solution. Now, in its current configuration, which we'll call the prototype configuration, it is rather cumbersome. We're using this, or I'm using this Node MCU with header pins, no less than 17 DuPont cables, and you know, it's just a little bit cumbersome. So I wanted to change it into permanent configuration, which is going to be a nice clean design. It's a permanent solution that essentially you can put anywhere, be it in your office or your workshop or something like that, and all you have to do is apply power to it. And yeah, that's what we're going to do tonight. Now, I will say at this point, this is actually take two. I ran into a problem with the wiring of the display, and I highlighted it to Brian. There was a slight error in his circuit layout. Essentially, this green wire here, he showed it connected to pin 4 on the right hand side of the out connector. It actually needs to be connected to pin 3 on the right hand side as you go down on the out connector. He has updated the video, which I will link to at the end of my video in a card about here, and provided links to the updated circuit layout or diagram, wiring diagram. I think that's probably more correct term. But yeah, now that that's been resolved, it's going to be fairly straightforward, and I will take you through that process. So if I turn this board over, you will see that it does have a few injuries where I was trying to access these connections down here with the soldering iron and you know, melted the frame slightly. I don't know why. Please don't ask me why. I don't know why I didn't do this. But this frame comes off. There are 6 tiny little screws like so that hold the frame onto the PCB, and if I just hold up the torch here, but I'll turn it round first just for a bit of contrast, you can probably just see, in fact I really don't think, yeah, can you just see about, yeah, you can see it now. Those screws actually go straight through the PCB. They don't protrude through too far, they're literally just into the PCB and no more, but that's what holds the frame on. Right, rambling slightly. This is the back of the board, obviously. What I've done is I've tinned up the required connections, so essentially all bar 1 on the in connector and a 5 on the out connector, and basically there is an interconnect required between these two, because we're using this as a single panel. These displays can be panelized, so you could have, you know, 2 up and 2 across to give you a bigger display, or you know, you can have it huge. Obviously the more you buy, the more hefty power supply you're going to require to drive it. Brian's code, you know, when it's running and updating, I think it peaks about 750 milliamps or 800 milliamps. It's really not a lot, and that's quite advantageous because it means we can use a typical mobile phone charger type, you know, micro USB mains adapter to power it. There's no requirement for a beefy external power supply. Okay, yeah, so how are we going to make it more permanent? We're going to hardwire it. What we're going to use some Kynar, some mod wire, some bodge wire, some wire rat wire, whatever you want to call it. Just single core, really fine wire, really easy to use. And rather than using the Node MCU like here, we're going to use one of these D1 mini clones. Super cheap off Amazon and places like that. I will pop a link down below in the description should you wish to purchase one through my affiliate link. You know, and that helps support the channel, as you know. Hope you don't mind me doing that. So we'll bring in our wiring diagram and we'll start off getting it connected up. Let's get the iron ready. Now, my iron is a little bit dirty. Don't know if you've seen this stuff before. I've had this for ages. It's just RS Components Tip Cleaner Restorer. It's got an abrasive powder through it, and flux and you know, tin and lead and all that good stuff. And if you just rub it through there, you will see it does restore your tip quite nicely. Cleans all the burnt on flux and, you know, other bits and pieces, and gets your tip ready for use, if I can say that. Anyway, so what we're going to do first is just do a couple of these interconnects. I'm going to do a few, and then we'll come back to the main event where we're actually hooking up the D1 Mini. Top tip when you're using Kynar, it is a solid core like I said. You don't want to be using wire strippers if you can avoid it. Just use your fingernail and pull the end off like so, and that's not going to damage the conductor inside. But first one we're going to do, we'll do this red one, which is going from the third pin down on the left hand side of the out connector, and hook that up to the top right connector on the in connector, if that makes sense. So like I say, I've pre-tinned these connections. So on this one, it's going to be the third down, like I say, and we're just going to go straight in with iron. Reflow that solder that's on there, like so. Give it a gentle pull, nothing too strong, and just to establish that it is actually hooked up there. We'll route the cable around like that. We will snip it, and we want to keep these as not tight, but we want to keep them as short as possible, just to make connecting it a bit easier, and a bit easier to tidy up, I should say. Okay, so this one's going to the top right, and I can trim a little bit off that. And then we will just reflow that again. Can. Now it might help actually if we use some tweezers here. There we go. By using tweezers we can keep the wire reasonably straight and get it into the location with minimum of effort, he says as he lets it go and it pings away. So there we go, get that in there. Reflow it. Again, a little gentle pull just to establish that it's connected, and there we go, that's our first wire in place. So now it's just going to be a case of following this wiring diagram, making the requisite connections, and then we'll get our D1 Mini in place and hook up these connections here. So I'll pause the video, do the donkey work here, and I'll come back to you when we're getting ready to hook it up, get my words out. Catch you in a moment. Okay, welcome back. Right, what I've done is I've done these interconnects between the two connectors, and I've pre-positioned or pre-soldered on the wires for the D1 Mini. I've also put a couple of wires to the ground and VCC connections here. Oh, we've got a little moth in the workshop. And these are common, so the two VCC are connected, and so the two ground connections here. So what this allows us to do is either power the display using the D1 Mini, or via the micro USB, or using the connector supplied. Either way it will power both the D1 Mini and the board itself. So I just soldered those on, as I said, and I've taped them down to stop any movement. And what we'll do, or what you can do if you're not confident, I'm reasonably confident, but I'll put my meter on continuity mode and we'll just buzz out these connections. So top right here, the blue, which is this connector here, or this pin here, goes to the third one down on the right hand side of this connector. So that's working. Pin 3 here goes to pin 2 up here. That's good. Red goes there, pin 3. Yeah, where does this one go? Pin 4, that's good. And finally the yellow goes to pin 3 on this side. So yeah, the interconnects are good. What I'm going to do now is position the D1 Mini. Now what I'm going to do is I've had a play about, and I think the best position for it to go is about here, because it still gives us access to the reset button should we require it. You know, not that a power cycle wouldn't do the same thing realistically, but it gives us access to the connector, and you know, it's going to be easy to solder. We're going to have space either side for the wires, and I think this is the optimal position in all honesty. So that's where I'm going to put it. What I want to do is put down some Kapton tape. The reason for doing this, one, it's an additional layer of insulation, but two, the double-sided tape which I'm going to be attaching the D1 Mini with is actually it's got really strong adhesive, and if it comes to the point that I need to remove it, it's going to be easier to remove the Kapton tape than it is the sticky pad. Now I am going over the top of this cap with the Kapton tape, and that will make itself, it'll be apparent why I'm doing that in just a second. And we'll pop another piece down there, like so. Right, so why have I insulated the cap? Well, it's a metal can on that, and we do have some components on the underside of the board, as we'll call it in this instance. And what I want to do is use the cap itself as a support for this board. So what we're going to do is going to take our double-sided pad. Now I've got a roll of this. I think I got it from a pound shop or something. And what I've done is I've stacked it 3 layers high, and we'll just plonk that on the bottom of the board on top of the cereal chip, the 340. What is it? A 340? I can't remember. And where that antenna is, we're just going to use that as a support and plonk it down there, like so. A gentle press, and as you can see, that's not going to move at all. Okay, now all we need to do is make the connections between the actual input connector and the D1 Mini. I'll do a couple, and then then I'll finish it off, and then we'll come back to when you're about to test it. But what I'll do first is, if I can get this to stop springing into my area of operations, is hook up the power lines to the D1 Mini. So we've got VCC, which is a 5 volts going there, and ground going to here. Now the ground connection, or the ground point on here, does have 2 connections. So the bottom right hand pin on this connector goes to ground as well. It's going to be easier to connect to the ground on here rather than the pin on here. There's a rather large ground plane, which is, I had to turn my soldering station all the way up to 450 to get that solder to melt. Clearly on here, where there's no huge great whopping great ground plane, it's going to be much easier to solder on here. But because we're using single core wire, it might take a little bit of tweaking to get it on there, without the wire pinging off, if that in any way made any kind of sense. So what we'll do is we will measure that up, trim it to size, bring it back around to give us a bit to play with, and strip it off again using our fingernails. Trim that to length. Now clearly, if you're trimming, in this instance I've had to trim that on the board, we're going to have to make sure that no little strands of wire have landed on the board and might cause a short later on. So we'll check that board before we power it, just to make sure that doesn't happen. So just going to kind of form the wire first, and then bring it into place. A little bit tricky. And just solder it on like so. There we go. So that's the VCC connected, and we'll do the same with the rest of the wire. So what I'll do is I'll get the majority done, and then we'll come back to you rather than bore you with me doing all that. So I'll catch you in just a moment. Okay, welcome back. Right, that's us finally got all the connections made. It looks like an absolute rat's nest, as you can see. But what we're going to do is just secure down these wires with some more Kapton tape, and this is just to make it a little bit more tidier, stop any potential movement, and any potential breaks. as we use this in the future, because obviously we don't want to be having to fault find it all the time. If you know, it's moving about and things are breaking and falling off, it's going to be a bit of a nightmare. So just a little bit of tape, let's say, we'll get it all stuck down to the board. So a little bit tricky in hindsight. I don't think if I was going to do this again, so take this as you wish. In hindsight, I don't think I would pre-solder the leads on. It was a little bit tricky in some cases to get the you know, work out which wire was going where and stuff like that. I think just doing it point to point, you know, moving along either the connector or the D1 itself, you know, pick a connection you're going to make it, then move on to the next one. And that is almost it, yeah. So let's just test fit. I'm not going to screw the frame on, I just want to make sure that it does fit and nothing's being you know, being trapped around that. That looks fairly nice. And I suppose the only thing left to do now is to test the thing. So we will take a USB phone adapter, or in fact this is a Raspberry Pi mains adapter. We will plunk it into the board. Just obviously support this as you do it. I saw a little flash, that's obviously a good sign. Oh, what's up? Connected to Wi-Fi. It should flicker. And there's my current subscriber count, which will probably be quite a few less than this after you've watched this video, because it did drag on and I was rambling so much. Yeah, that's quite nice. And as you can see, I don't think that's going to stand proud of the board. Yeah, we've got a good couple of millimeters above that, which means we could potentially mount this flat to a wall or whatever, using some sort of you know, we would come up with something and get this mounted. But that's really nice. It's a one-off unit. Sorry, a one-off unit. Well, it is, I suppose, just now. It's a one-stop board. You don't need to do anything else. You just plunk power into it. And of course, if you wish to do so, you can. We just get the bench supply here. We'll get the supplied power connector, hook that onto the board and verify that it's not going to be trapping any wires. That's good. Hook this up here. I've got 5 volts. It's actually set to 3 amps. I'll turn it on. Saw a flash, that's good. Currently drawing 170 milliamps, 235, 415, and I lied to you at the start of this video. 650, well, a peak 648 milliamps by the looks of things. Clearly, if this is all 8s, then that'll probably bump it up to maybe, you know, 7 amps top, something like that. But yeah, really nice little board. Sorry, I am rambling again. Something I didn't mention, which I'll mention now. You may notice when often this is flickering. Now, Brian reckons this is because it's, you know, the ESP8266, you know, single core process, fairly low powered. It's just when it's trying to, you know, pull the data from Google servers, as it updates, it flickers the board. The Wi-Fi LED, this blue one here, I think maybe an effect. I think maybe that the pin that's on is obviously connected to this. Do you see it flickering there? I don't know if the camera would pick that up. Yeah, that flickering happens at the same time, so it might be that one of the I/O pins is causing that as well, rather than just the, you know, being low processor power. Hopefully that made sense. But as I said to Brian, I actually quite like it. We had a chat about it, and I actually quite like it. It's like flickering, and you know, it catches your eye and you go, oh, it's updating now, is there any change, that kind of thing. So yeah, as he said, all programmers say bugs are just extra features, aren't they? Right, okie dokes. Thank you very much indeed for watching. I hope you did enjoy this video, found it useful. It's a great little project. You're gonna have a nice self-contained unit, like I say, that you can put wherever you wish and only have to connect power to, and it'll just work. So yeah, if you did enjoy it, give me a thumbs up. If you didn't, please give me a thumbs down. I really don't mind which way you go, as long as you give me some sort of feedback. You know, that's good for me and all the YouTube magic that happens in the background. So please thumbs up or thumbs down. Of course, add comments if you would like to do so. And that's pretty much it. If you haven't already subscribed, please click on my fat head down here and do that. Also click the little bell notification if you'd like to see some of my other videos as I upload them. But that's about it. Until next time, as always, take care of yourselves and all the best.